Hi guys, welcome to section 9.3. This is the third of our transformations that we're going to talk about. We're going to talk about rotations. They're an interesting little group, and we've got some rules, a few sets of rules that we need to talk about, and we're actually going to limit. We're not going to get too crazy with rotations. We're always going to use a coordinate plane, and we're always going to rotate around the origin. However, once we finish rotations, we're going to take a little bit of a break. We're going to quiz, discuss. We're going to have a fun little graphic organizer that we're going to make. And get these first three congruence transformations taken care of before we go out to dilation. So we've got a little break at this point. So first of all, let's talk about rotations. Got a little wordy here, but a rotation is a transformation that turns every point of hold on one second, a transformation that turns every point of a preimage through a specified angle and direction. So direction is something important we need to talk about, and then angle we need to talk about. That fixed point that we're always going to use is the origin. So we're always going to rotate around the origin, but we do need to talk about the angles and the directions. So, first of all, the direction of rotation will either be clockwise or counterclockwise. Assume that it's counterclockwise. If I don't say otherwise, that's like the default setting. Does everybody know an old-fashioned clock? Because that's kind of important to know clockwise or counterclockwise. So clockwise, it kind of goes along with your locker, right? Right or left. So counterclockwise, this is our default. I try not to get too sneaky, but every now and then a problem will go in there that'll say, 180 degrees clockwise, and then we have to figure out what is that counterclockwise. So notice on this little diagram, I've got point A. This is my pre-image, and I'm going to rotate that 120 degrees counterclockwise. So here's my 120 degrees. It's counterclockwise, so it's going towards the left. And that A prime ends up being out here, equidistant from that point of rotation, which will be the origin. And if we took out a protractor and measured, it would be 120 degrees. Now, we're not going to do anything crazy like 120 degrees. We're going to stick to our basics, 90s, 180s, and 270s. So we don't have to get too crazy with measuring and everything else, but we could do that. This is also a congruence transformation, like I mentioned. So our point, our triangle, our whatever we've got is exactly the same size and shape. When we have an image compared to its pre-image, there's no change except for the position on the coordinate plane. So let's talk about our rules. We've got three rules. The first one is a 90-degree rotation. Remember, that is counterclockwise. We're always going to use the origin. So if you notice on the example on the side, I've got point P is at 5,2, and I want to rotate that 90 degrees. Well, in order on a coordinate plane to get an exact 90 degrees, you really need to use the rules and put it on the coordinate plane, not put it on the coordinate plane and find the ordered pair. So here's what the rule is for a 90-degree rotation. Your ordered pair xy becomes the ordered pair negative y x. So 90 degrees, you switch the two values, x and y values, but you also change the sign on your new first value, which was previously your y. So if we practice this to find p prime, I switch the two values from 5,2 to 2,5, and then I change the sign on my new first term, which was my my y value. So at negative 2,5, I should have a point P prime. If I draw a dotted line from the origin to P prime, from the origin to my pre-image P, and measured it out, that would be a nice, neat 90-degree angle. So the rule is your ordered pair xy goes to a negative yx. 180-degree rotation, we've got the same pre-image point P at 5, 2. To rotate your point 180 degrees counterclockwise, multiply the x and the y coordinates by -1. So in other words, your xy ordered pair becomes negative x, negative y. Notice it doesn't say to interchange like it did on the last one. It just says to multiply both of those coordinates by -1. So my P prime, everybody knows 180 degrees, right, is half a turn. 365 is one full rotation. So my P prime should land down here in quadrant 3. And if I just take my ordered pair 5, 2 and follow that rule, P prime now becomes -5, -2. So if I go back 5 and down 2, put a point, I should be able to draw a dotted line. By the way, this is 90 degrees counterclockwise. I should, from that origin as my center, be able to measure 180 degrees counterclockwise. If you go clockwise or counterclockwise, does 180 degrees change? Same thing, right? Because you're still going a half a rotation, we would land at exactly the same place. So that one's a little bit easy to check. We'll come back to the first one. So our last rule, last and final rule, is a 270-degree rotation. So if we're going to rotate a point 270 degrees counterclockwise, multiply the x-coordinate by -1, and interchange the two coordinates. So my xy ordered pair becomes multiply the x-coordinate by -1 and interchange, so I end up with a y, -x. So starting off with my same point P at 5, 2, if I'm going to rotate this 270 degrees, that's 3/4 of the way around, right? So I should land down there in quadrant 4. If I'm going to write out my coordinates for P prime, I'm going to multiply that x coordinate by -1 and interchange them. So I should have a 2, -5. So over 2 down 5, I should end up with a P prime somewhere over there. If I draw that dotted line and measure that angle, that should be 270 degrees. How many degrees would that 270 degrees counterclockwise? What would that be if I went in the other direction? What if I went clockwise from P to P prime? That would be 90 degrees clockwise, right? So sometimes they'll throw a little sneaky problem in there and say, oh, 90 degrees clockwise. You have to have a red flag go off in your head and say, I don't do clockwise. However, I know that 90 degrees clockwise is 270 degrees counterclockwise, and I know the rule for that. So everything that you need to know is there if you just watch out for those sneaky little situations. So there's our 3 rules for rotations. We're never going to get crazy and use a different point other than the origin. We're just going to use the origin, and we're just going to use those 3 basic values. So let's talk about triangle PQR. Tells us the vertices. It says to graph the triangle and its image after a 270-degree rotation about the origin. So our best bet would be to graph this. So point P is at 1, 1. Point Q is at 4, 5. Point R is at 5, 1. So here is my triangle. I want to rotate that 270 degrees about the origin. Does it say direction? So what direction do you know since it is not stated, our default? Counterclockwise. So 270 degrees counterclockwise, our rule is xy becomes y negative x. So that means that my p prime, what quadrant should our 270-degree rotation of triangle PQR land in? Should land down here, right? In quadrant 4. So p prime, p starts out at 1, 1. I'm going to multiply, forgot a comma there. I'm going to multiply my x coordinate by negative 1 and then interchange, which means I'm just going to end up with a 1, negative 1. Q prime, I started off with a 4, 5 for my ordered pair. I'm going to multiply that 4 by negative 1 and then switch them. So I'm going to have a 5, negative 4. And R prime, I'm starting off with a 5, 1 for that ordered pair. I'm going to multiply the x coordinate by negative 1 and interchange them. So I should have a 1, negative 5. Let's get these guys on the graph and see if it looks like a 270-degree rotation. So I've got point P prime is at 1, negative 1. Point Q prime is at 5, negative 4. And R prime is at 1, negative 5. 2, 4, 5. Sometimes it's harder to see the rotation because remember it turns. So it's got to actually rotate. So this would be a 90-degree rotation. This would be a 180-degree rotation. This is what it should look like if it's a 270-degree rotation. And then it's also got to move around that origin. So it does end up having the same shape. It just gets rotated. What you think of those ones? So really what it comes down to for rotations is knowing the rules and knowing how to change your ordered pairs. Let's do number 2. I think we'll be okay to skip number 3, but let's do 2. So let's put triangle JKL, our pre-image, on the graph, and then let's do a 270-degree clockwise rotation. So first of all, point J is at 3, negative 7. 4, 6, 7. Point K is at 1, negative 1. And point L is at 5, negative 3. So we've got our pre-image down here in quadrant 4. So now we've got this. So we've got 270 degrees clockwise. Do we rotate clockwise? What is 270 degrees clockwise? If I start right here and I go clockwise 270 degrees, I would land right here, right? But I don't want to go clockwise. So what's 270 degrees if I go counterclockwise? I've got myself a 90 degrees counterclockwise rotation. So now I can go to my rules. My XY ordered pair for counterclockwise becomes multiply the y coordinate by negative 1 and interchange them. So negative yx. Yes, I'm going to ask you to write your J prime, K prime, and L prime. I know, it's a lot of work. So J prime starts at 3, negative 7. Sorry, yeah, 3, negative 7. I said that right. So that means I'm going to multiply my y coordinate by a negative, and then interchange them. So it seems to me that my J prime should be at 7, 3. K prime, multiply the y coordinate by negative 1 and interchange them. So a 1, 1. And L prime, multiply that y coordinate by negative 1 and interchange them. So I'm going with a 3, 5 on that one. Let's put our image on the graph. So J prime is at 7, 3, 2, 4, 6, 7. K prime will be at 1, 1. And L prime will be at 1, 2, 3, 5. So my 90-degree rotation takes me one quadrant, so I end up in quadrant 1. If I rotate this 90 degrees, I've got myself identical pre-image and image. But again, I'm going to go put it back to where it was. Whoops. Whoa, now everything's moving. Let me try that again. There. Put everything back to where it was. Our L prime rotated 90 degrees. Our J rotated 90 degrees. And our K rotated 90 degrees. So what do you think of these? Are these ones okay? Do we need to talk about parallelogram FGHJ, or do you feel like you've got it? That one's 180-degree rotation. That's probably the easiest of the 3 rules, so I feel pretty okay with skipping that one. Our rule is XY becomes negative X, negative Y. So you should move 2 quadrants from where you started off, and it should be flipped over because we're rotating at 180 degrees. So that's the end of section 9.3. I'm excited to stop here and take a break and regroup and talk about these first 3 types of transformations, and then we can start talking about dilations after that. That's it. We'll have a great day, and we'll talk to you next time.